section 11.2, we're going to continue with conic sections, and we're going to talk about the parabola. So first of all, for the definition of a parabola, it's going to be the absolute value of the distance from x to p, and the distance from x to q is going to be k. So what that means is, if you look in this diagram I have, if you choose x, so x being any point on the hyperbola, so it could be on the left side or the right side, and the graph of the hyperbola is actually the piece in red. So you choose any point on there, and you choose points P and Q. P and Q are going to be your foci. If you take the distance from P to X, and then you take the distance from Q to X, and you subtract those, taking the absolute value of those distances, it's going to be the same, equal to some value K, as it would be if we were to put X in a different spot on the hyperbola. All right, and so let's look at an animation of this to help you a little bit. Here you have, what you have is on the leftmost point would be your P, and then on right would be your Q. And the point that's changing there is going to be your X value, the value that's on your hyperbola. In this case, it looks like on the right side. But what you notice is as you subtract the green from the blue, then that difference stays the same no matter what, and you can see that at the bottom of the diagram there. All right, and so some important points on the hyperbola are P and Q. P and Q are going to be your foci. You have your vertices, so your vertices are here and here. Your vertices are actually points on the hyperbola, whereas P and Q are not points on the hyperbola. They're just very important points. You have the center. The center is going to be here. And then you also have hyperbolas that open left to right or up and down. So that's going to give you a major and a minor axis there, just as we had with the ellipses. We're going to work through a couple of example problems. The first one, we're going to show that the graph of the equation 4y squared minus 16x squared is equal to 64 is a hyperbola. We're going to graph it and its asymptotes and find the equations of the asymptotes and label those in the foci and the vertices. So the other thing I didn't talk about over here is that you do have asymptotes. Again, you have two asymptotes, and those are helpful in graphing and guiding us where to graph, but they are not part of the graph of the hyperbola. Okay, so let's get started working on this one. We're going to start with the equation 4y squared minus 16x squared equals 64. We're going to divide everything by 64 to get us equal to 1. All right, and once we do that, we know we're going to end up with y squared over 16 minus x squared over 4 is equal to 1. At this point, it's obvious that what we have is a hyperbola. We know it's a hyperbola because we've got a y squared minus an x squared is equal to 1. And if we're going to find those a, b, and c values, then we might want to rewrite this one more time to y squared over 4 squared minus x squared over 2 squared equals 1. Okay, from there, we notice that the 4 is larger than the 2 in the denominator, which means that our hyperbola is going to open up and down instead of left and right. So at this point, what I like to do is just go ahead and sketch what I think is going to happen and then label it as, so I don't put any numerical values on here. I just say, okay, so I know it's going to open up and down. So I've got two asymptotes here. And let's go ahead and get our graph in green. So and there's our graph. And the things that we'll need to find points for our vertices here in red. Those are our vertices. And we're going to need to find our foci, which I'll put in blue, which are going to be just on the outside of that. Okay. So part of this is sort of easy to answer at this point, and then part of it we're going to have to do a little bit of work for. Make that a little bit smaller. Okay, let's do the easy part. So far we have our vertices. And our vertices, what we're going to do, we know they're on our y-axis. So since they're on our y-axis, the x-coordinate is going to be 0. And we need to think, and there are red spots here and here. They're going equidistant up and down that y-axis. So if we look at this 4 here, this 4 is going to tell us that since it's 4 squared, it's going to move up 4 and then down 4. So vertices are going to be at positive and negative 4. Right? And then now let's go to our asymptotes next. So we have all the information we need to find our asymptotes. All right. Our asymptotes are linear equations. So they're going to be at y equals plus or minus. Now the way we find those is slope is rise over run. So you look at the, again, rise is going to be, you think of as your y, and run your x. So it's going to be 4 over 2. So in this case, plus or minus 4 over 2, which is just 2, x. And so we could say plus or minus 2x. Those are going to be our asymptotes. And then the last thing we need to do is come up with our foci. Now, each focus is going to be equidistant from the origin there. And the way you find your focus is, again, you use a triangle. Now, that 4 and 2 that we've used earlier, we're going to use again. Those two are going to give us the legs of this. This right here is going to be the difference that the focus is from the center, and that should be 4 and 2, not 4 and 4. Okay, so we're trying to find the hypotenuse. So when we find the hypotenuse of that, then we know how far the focus is from the center of our hyperbola. Okay, so we've got our focus squared is going to be equal to 4 squared plus 2 squared. So that means f squared is going to be 20. And then f is the square root of 20, plus or minus. Okay. So again, our focus is going to be on our y-axis, so that tells us that x-coordinate is 0, and our y-coordinates are going to be plus or minus root 20. So, you know, just a little bit further than the vertices are. Root 20 is going to be just a little bit more than 4. And that's all I have for that problem. And in example 2, identify the graph of 5x squared minus 4y squared equals 20, and then graph it on a calculator. So let's start by just working on that equation a little bit. You notice it does have an x squared and a y squared, so it's likely a conic section. We're going to divide everything by 20. And when I do, I get x squared over 4 minus y squared over 5. It's equal to 1. Okay, from here I might want to rewrite it as x squared over 2 squared minus y squared over root 5 squared equals 1. All right, so what we have is a hyperbola because of the minus. Now, when we go to graph this on the calculator, we have to look at a different form of the equation, all right? What we need to look for is we need to solve for y. So let's work on it again for our calculator. We've got our 5x squared minus 4y squared equals 20. I'm going to say solve for y. So I've got negative 4y squared equals negative 5x squared plus 20. I'm going to divide everything by negative 4. And when I do that, I end up with y squared is equal to 5/4 x squared minus 5. And then I take the square root of both sides, plus or minus 5 over 4 x squared minus 5. Now, just like last time, I'm going to need to use y1 for the positive version of this and y2 for the negative version of this. Otherwise, I only get half of my graph of this hyperbola. So here you can say I have both of those entered into my calculator, and I'm going to go ahead and graph those. And you can see that I have a hyperbola, and let's just find out if it's what we thought it would be. We have a hyperbola opening left and right. Um, and we have it opening left and right because the negative, you got the negative y squared over 5 here. Um, okay. And so it is what I expected it to be. You've got your negative, as I said, you've got this negative. And this one is larger. The negative is with a y. So that means it's going to open left right because x is going to be our positive one. So that makes it open left and right. Whereas if you look at the previous example, see, we have left right here. We have up down opening up and down in this case, and we have it opening up and down because our y value is our positive here. So that makes it open up and down. And our third example, this is our final example for this section. We're going to find the equation of a hyperbola that has vertices at 2, 0 and negative 2, 0 passing through the point 4, root 3. And then we're going to sketch its graph by using the asymptotes and label in the foci. So this problem is a little bit different. It gives you a point on the hyperbola. So what we're going to do is start out with x squared over something squared minus y squared over, say, b squared. Well, let's just leave this as something squared again equals 1. Okay, so what we know here is that it has vertices at 2, 0 and negative 2, 0, meaning it's going to open left and right here. So if it opens left and right, then that means that the x squared is going to be our positive. And so it also means that this value here is 2. We don't know what this value is, so we're going to call it b. And we know it passes through the point 4, root 3. So what we're going to do is use that as our x and that as our y to then try to solve this problem. So when x is 4 and y is 3, then we should be able to plug it into this equation and solve for b. So I've got 4 squared over 2 squared minus root 3 squared over b squared is equal to 1. 4 squared over 2 squared is going to give me 16 over 4 minus root 3 squared is going to give me 3, and b squared equals 1. And so I end up with 4 minus 3 over b squared equals 1. And now I can subtract that 4 from both sides. And when I do, I get negative 3 is equal to negative 3 over b squared. And from here, I can multiply both sides by that b squared, and I get negative 3. B squared equals negative 3, which means that b squared is equal to 1. And I take the square root of both sides, and I get b is plus or minus square root 1. Or square root of 1 is just 1. All right, so now I know what b is, so I can go back and plug that into my equation up here. Okay, giving me x squared over 2 squared minus y squared over 1 squared equals 1. And now the next thing is to sketch the graph and label the asymptotes. So as I mentioned earlier, when I sketch the graph, I just start out and then I go through and I'll label as I need to. So what we know about this one is that it's going to open left and right because our x squared is positive. So let's go ahead and sketch our asymptotes. And then vertices and sketch our graphs. It's going to get very close to those asymptotes, but it's not going to touch it. Okay. And so then, again, the points we need to find are our vertices. Okay. And in blue, I'm going to put our foci. And then, of course, the equations of our asymptotes. All right. So start with our vertices again. So our vertices are going to be on the x-axis. So since we're on the x-axis, there are our red points here, and we look with the x, and we've got a 2 squared here. So the vertices are going to be at plus or minus 2, 0. Then our foci. In this case, what we're going to have to do is use a right triangle for this. All right, so we have a triangle. We know that our 2 and our 1 are going to be the legs of that triangle. And then what I'm trying to find is f. So f squared is going to be equal to 2 squared plus 1 squared. And so f squared is equal to 5. And then f is equal to plus or minus root 5. And so that's the distance they are from the center. So plus or minus root 5, 0. And then the last thing we need to find is our asymptotes. And our asymptotes are going to be linear equations, plus or minus, and rise over 1, run y over x. So we've got 1 over 2x. And here we have the equation, everything we need. There is one more example in this packet of notes, but we're going to leave that for class as well.